So oftentimes students are learning about the sine, cosine, and tangent curve, and they have a lot of difficulty trying to understand how to come up with this curve. So what I want to do in this video is I want to show you using the unit circle and how we're actually just plotting the graph through the different quadrants. So I'm going to start with the sine curve here. Let's go with sine graph. But before I do the sine graph, what I'm going to do here is I'm going to do a unit circle. And we have to remember the unit circle. In the unit circle, we have, where is that? Get something much straighter. Okay, so in the unit circle, we have this. We are going to start, this is 0 here. This is 90 or pi over 2. This is 180 or pi. And then this is 270 degrees or is degrees here and degrees here, or 3 pi over 2. And here we have 2 pi or 360 degrees. So what we have to remember when we're drawing the sine graph is that when we are in the unit circle, we have our coordinates as cosine, sine. So here, where we have, remember our unit circle, we have 1 here, 1 here, -1 here, and -1 here. So let's just go ahead and just draw this circle. Okay, so here we have x is 1, y is 0. Here we have 0, 1. Here we have -1, 0. And then here we have 0, -1. So what I want you to remember here is that the x coordinate represents cosine and the y coordinate represents sine. So if we want to focus on the sine graph, here's what we're going to do. We're going to draw our axis here, and we're just going to go from the first quadrant and we're just going to go around. So let's go ahead and have 0, and then we have pi over 2. We have pi, then we have 3 pi over 2, and then we have 2 pi. So here our sine at the beginning is 0, so we're going to start over here at 0. And then at pi over 2 it's 1, so you can see that here. Then we get to pi, it is 0, we come back here. At 3 pi over 2 it is -1, so we come back here, and at 2 pi we get back to 0. So this is what the graph is going to look like. Go down here, and then we end over here. So this is simply what our sine graph is going to look like. Now, what if we had to do a cosine graph? This is where, and if you understand this concept that the sine, cosine, and tangent graph are actually derived by just going through the 4 quadrants in the unit circle, this makes it a lot easier to understand. So now let's go ahead and try to draw a cosine graph. Let's erase this here. And we're going to draw our cosine graph. Okay, so with our cosine graph, this is cosine graph. Let's go ahead and draw our axis here. Well, here we're going to pay attention to cosine, which is the x value at each of these points on the unit circle. So we're going to start 0. We have pi over 2. We have pi. We have 3 pi over 2. And then we have 2 pi. So at the beginning here, we have 1. So we're going to start here at 1. Then we go to 0. We go down here to 0. Then here to -1, which is right here. Then we go to 0 again. And then we go to 1 right here. So now we're going to try to follow the path. So we start here, go to 0, to -1, to 0, and then, so that's what our cosine graph tends to look like. Now, there shouldn't be much of a hassle trying to understand this. We can see here that as we go through this quadrant, you'll see that we are following the path of, we're following the path of this unit circle, and we're also paying attention to something really important, the value of this trig ratio at each of the quadrants. You can see here that we start here where every value, I'm going to introduce you to this, is a cast, C-A-S-T, or some will say all students take calculus if you're going from quadrant 1 through quadrant 4. And here, this simply means that all trig ratios are positive in the first quadrant. In the second quadrant, what you're going to see here is only sine and its derived ratios are going to be positive. So here we're talking about sine and cosecant. And in the third quadrant, we have tan and its derived ratios. So we have tan and cotangent. And in the fourth quadrant, we have cosine and secant. These are the only ratios that are positive in this quadrant. And we can see that here, if we were to draw a line right here, let's try to draw a line right here, right here, right here, and then right here. What you will see here is that from this is 0 here, this is quadrant number 1, this is quadrant number 2, this is quadrant number 3, and this is quadrant number 4. So you can see here for cosine, quadrant number 1 is positive, quadrant number 2 is negative, quadrant number 3 is negative, and quadrant number 4 is positive. So that's pretty much how understanding the unit circle makes all of these very simple to understand. Now, we're going to go to tangent, and that's where this application becomes so much more relevant. So I'm going to go ahead and erase the screen. Okay, so we're going to talk about the tangent graph, or the tan graph. So let's go ahead and we're going to draw. Now, what we know about tan is that the period of tan is pi. So what we're going to see here, I'm going to just go ahead and draw this. This is pi over 2, and then pi. So what it simply means is that the graph behaves the same every pi units. Now we are going to look at something very unique here. And what we're going to see here is that we start off positive, and then we go to negative, then we start positive, and we go to negative. That is really what we're trying to see with this period. Now, a few important things, but I'm going to draw this all the way to 2 pi, just so that I can show you something. So this is 3 pi over 2, and then this is 2 pi. So remember that tan is your sine of the angle divided by the cosine of that angle. So we have to remember that anytime in any of these points where sine is 1 and cosine is 0, we're going to have an asymptote. An asymptote means that the function is undefined at that point. So what that tells me here, if I look at this right here, 90 degrees, so this is cosine. Remember, this is cosine and this is sine. This is 1 over 0. Sine over cosine is going to be 1 over 0, which is undefined. So we're going to have an asymptote at pi over 2. We're going to have another asymptote right here at 3 pi over 2. So now let's go ahead and just walk through the graph. So here, tan is 0. So at 0, we're going to start from 0 and we're going to stay on the positive side of the y. We're going to stay above in the positive y-axis until we get to the asymptote. So this is what we're going to start here, and then we're going to go towards the asymptote. Now we get to the asymptote, and here tan is negative. So that means that we're going to go from the asymptote on the negative side until we get to right here where tan is 0. So we're going to start from here, negative part of the asymptote here, and then we go all the way to 0. Okay, so now we have covered the first two quadrants. Now let's go to the third quadrant. Here, tan is positive, and we're going to go from 0 until we get to another asymptote. So we go from 0 until we get to the asymptote. And then here, tan is negative. So we go from the asymptote on the negative side, on the negative y, until we get to 0 again. So you can see how important this unit circle can be, or is rather, when you are trying to draw the graph of trigonometric ratios. And so I just wanted to make sure that you understood the relationship between the unit circle and your ability to comfortably and confidently draw the graph of trigonometric ratios. For pre-calculus students, there's a topic that tends to be challenging for them, and that topic is graphing trigonometric ratios, and that is with looking at the sine, cosine, tangent, cosecant, secant, cotangent. And I think what makes it difficult for them is not understanding that when you understand the unit circle, a lot of things actually stem from that, and that's why a lot of teachers or pre-calculus teachers pay a lot of emphasis to learning the unit circle. So what I'm going to do is I'm going to draw our coordinates, and we're going to use that to generate a sine graph and maybe a cosine graph, and let's see how things go. We may do a tangent graph as well. So let's go ahead and draw our coordinates right here. So these are coordinates. This is 1. So we have 1 right here, we have 1, we have -1, and we have -1. And now we have to remember that we're going to go counterclockwise here. So that is in that direction. We're going to go in that direction. So let's join this and try to create something that looks like a circle. And this is going to be our unit circle. Okay. So we often have, whenever we have coordinates, we write it in the form xy. But when we are dealing with trigonometry, we're going to write it we're going to write the point as cosine sine. So this is going to be 1, 0. This is going to be 0, 1. This is going to be -1, 0. And this is going to be 0, -1. And we're going to use radians for this lesson here. So this is going to be 0. And I'm going to use a different color to write that. So this is going to be pi over 2. This is going to be pi. This is going to be 3 pi over 2. So here's what this is telling us. Remember that our x coordinate is cosine and our y coordinate is sine. So now let's go ahead and draw our graph right here. I'm going to go from 0 to 2 pi, and let's not forget that there's a 2 pi here. Let's go 0 to 2 pi. So what we have to do now is I'm going to do, because if you look at the coordinates here, the axis here, where our degrees are, well, our units of our angle units are separated by pi over 2. So I'm going to have right here 0. I'm going to do a pi over 2 here. I'm going to do a pi over here. Then 3 pi over 2. And then I'm going to do a 2 pi over here. So when we are trying to draw the sine graph, we're focused on only the y coordinates. So we're going to focus on the y coordinates. So if you look over here, you're going to see that at 0, your y coordinate is 0. So we're going to draw a 0 here. And your maximum here is 1. And your minimum here is, your maximum value is 1. Your minimum value is -1. This is what you call the amplitude. I will get into that later on. So we get from 0 here, and then we go to pi over 2, y is 1. So we come over here. Then we go to pi, we get back to 0, y is 0. Then we go to 3 pi over 2, we get -1. And then we get 2 pi, we go to 0 again. So now let's join this together and see what we have for our graph. So we have 0, 2 pi over 2, 2 pi, and then we come down to 3 pi over 2, and then we go to 2 pi. So now this is your standard sine graph. So this is y equal to sine x. So this right here is y equal to sine x. Now let's go ahead and try to draw the cosine graph. And we're going to follow the same technique right here. So we're going to have 0 here. Then we have pi over 2. We have pi. We have 3 pi over 2. And then we have 2 pi. And our maximum values are going to be, the maximum value of cosine is going to be 1. The minimum value is always going to be -1. So now we're drawing cosine, the cosine graph. We're going to focus only on the x values, the x coordinate values. So let's go ahead and start drawing. So for our x coordinate value for 0, you can see that is 1 right here. So we're going to start here. And then we go up to 0. Then we're right here. Then we go to -1. We're right here. Then 3 pi over 2, we go back to 0. And then at 2 pi, we go back to 1. So let's join this together and see if it looks like the graphs that we tend to see whenever we have memorized the cosine graph. So we start at 1, we go down to 0, we go to -1, go to 0, and then we go to 1. So this is simply how that graph is generated. Now we're going to do something unique, and that is try to draw the tan graph. Now let me write this is y equal to cosine x. Now we're going to try to draw a tan graph. Now tan is unique because we have to remember something very important about generating your tan. Your tan is going to be sine divided by cosine. So let's go ahead and let's draw an axis and get something going. So we have right here, we're going to do the same thing. We have 0, we have pi over 2, we have pi, we have 3 pi over 2, and then we have 2 pi. Now, when we have sine over cosine, we have to remember something here. There are some instances where sine is 1, and cosine is 0. This is going to be undefined. 1 over 0 is undefined, so we're going to generate what we call an asymptote. And an asymptote is a line that the graph can never touch, because at that point, the graph is actually undefined. So we're going to draw some dotted lines to indicate our asymptote. So what's the easiest way to figure out where our asymptote is going to be? Our asymptote is going to be anywhere that sine is a non-zero value and cosine is a zero value. So you can see just by looking at the graph that your asymptote will generate at pi over 2 and 3 pi over 2. So let's go ahead and just do that. Let's draw our asymptote at pi over 2 right here and 3 pi over 2 right here. Now, a few things that we have to remember. Where is tan going to be positive and where is tan going to be negative? So we can see here that from there's a way to remember. So we can say this is all trig ratios are positive here, all sine trig ratios are positive here, all tan trig ratios are positive here, and all cosine trig ratios are positive in this quadrant. Now, there's a simple way to remember. Just remember that you have y over x. Your tan is always y over x, which is sine over cosine. All you're seeing here is that in this portion right here, your your y value is positive, your x value is negative. That is why you have a negative tan here, and here both are negative, so you have a positive tan value. I think I'll probably do another lesson just focusing on that. So let's go ahead and try to figure out what we're going to do with our tan graph here. So if you look at our tan graph here, we start off at 0 because sine over cosine is 0. Sine over cosine is 0 right here. I'm going to use a different color here just so we can see it more clearly. So let's use this one right here. So it's going to start from 0, and you can see that because your values of, notice here that your values of sine continue to increase, but your value of cosine continue to decrease. So you're going to have something that looks like this at that point. And then we're going to see also that at pi, the tan of pi is going to be 0. So we're going to draw a line right here. So now we go over to our asymptote, and then our asymptote in this quadrant, tan is negative. So we're going to go from the negative part of the asymptote, come all the way here, and then we are going to go over here where we're going to get to another asymptote, but in this quadrant, tan is positive. So we're going to come right there, looking like that. And then we end up going from this asymptote to 0. We go from this asymptote right here to 0. And you can see that tan is negative from this asymptote right here to 0. So you're going to have something that looks like that. So this is actually your tan graph. And you can see that it's so easy to imagine your tan graph when you start looking at the fact that your unit circle becomes almost like a super guide in drawing this type of graphs. So if you have any questions, just leave a comment in the comment section, and if you need some more clarity on that, feel free to let us know. And as usual, if you want one-on-one, if you like this style of videos and this type of learning, and you like a one-on-one session, there will be some information in the details on how you can reach us for